Okay, so today we're going to talk about compositions of transformations. So when we think of the word composition, okay, basically when we compose something, we make something new. We bring parts of something together. And so basically what you're doing here is you're taking one transformation, you're getting an image, and then you're putting on another transformation on top of it. It's not too difficult. Basically, I think about this as two transformations. So let's go ahead and look at this. It says triangle ABC with vertices A, -1, 0. So here's where A is. Okay. B, 4, 0. So here's B. And C, 2, 6. Okay, is first translated. So first of all, here's my first triangle. Now this is one that if you pay attention, it shouldn't be near as hard as it looks. It's first translated by the rule, xy, x minus 6, y minus 5. So what does x minus 6, y minus 5 mean I do with each of these points?
You take x.
Go where?
Wait. Oh.
Okay, then what do I do?
Down 5.
Okay. So here's where A prime is. So let's review again what that x minus 6 means. It means I'm going to go -6 to the left. I'm going to go 5 down. So B, I'm going to do, okay, then I'm going to go 5 down. So here's my new B prime. And then C, I'm going to go 6 to the left, and then 5 down. So here's C prime. So here's what your first one looks like. Oh, a little off on that one. Let's try that one again.
I do that a lot.
There we go.
Just like cut.
Now I'm going to translate this to the rule x plus 14, y plus 3. So what do I do with each of these?
X plus 14.
Okay, yep. So here I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I'm going to go up 3.
Wow.
So this is a double prime. Notice we use just another prime. So you notice a double prime? So B. Okay, and then I'm going to go up 3. So here's B prime. Or B double prime. And then C, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then 1, 2, 3. So here's C double prime. So here's my final image. Okay, now they say what single translation is equivalent to the composition of these two translations. So they want you to do purple to pink. So what can you do to purple to get the pink one? So let's think about that. X comma y,
No.
2, x what?
Plus 2.
No, it's going to be way more.
X plus, yep, 8, and then y
Minus 2.
minus 2. Now, real quick, did you necessarily have to count purple to pink? And the answer is no. Look at these.
Dang.
You see you've got x minus 6, x plus 14. Net result would be positive 8.
Yeah.
Y minus 5, y plus 3. Net result would be y minus 2. So those are two ways you can look at it. If you're a visual learner, it might help to have the visual. Okay? If not, you can sit there and look at the numbers, since I know a lot of you like algebra. What single translation brings the second image, the pink, back to the position of the original? So I want to go pink to purple. So pink to purple. So what am I going to do to the pink to get to the purple?
Minus 8 plus 2.
X minus 8, y plus 2. What did you do?
Just reversed it.
Reversed them. You flipped them. Now when we say reverse, we meant you changed the signs. You didn't flip the x and the y. You just made the negative 8 or made the positive 8 negative, made the negative 2 positive. Okay? All right, so real quick, let's go ahead and look at page 384 in your book. Okay? Page 384 in your book says a reflection across parallel lines. Now, if you look at that investigation in your book, so notice step 1 to 2 to 3 to 4 and to 5. Okay. What can you tell me about the original figure you started with and the final figure you ended with?
Same thing.
They're the same thing. So what you've done is you reflected it once, you reflect it again, and notice that you have the same image there. And so let's go ahead and look at this. It says a composition of two reflections across two parallel lines is equivalent to a single. So let's think about what this is saying. A composition of two reflections across two parallel lines is equivalent to a single what? Translation. Okay? A single translation. Now let's look at the next thing. In addition, the distance from any point to its second image under two reflections is twice the distance between the parallel lines. And that should make sense, because we just kind of looked at that. Okay, so on page 385, there's another investigation, the reflections across two intersecting lines. And so if you look at this, notice we start on page 385. We start with an image, we reflect it, and then we draw another intersecting line, and we reflect it again. So when you look at that original figure from step 1 to step 7, what does it look like?
Rotation.
A rotation, very good. So a composition of two reflections across a pair of intersecting lines is equivalent to a rotation. The angle of
The two reflections.
the angle of rotation is
90 degrees.
twice the acute angle between the pair of intersecting, reflecting lines. Okay, so you have your lines that intersect, whatever that angle is, your rotation will be double that. And that should make sense because you're doing two things. You're reflecting it twice. Okay, so next, and the very last thing we're going to talk about today is a glide reflection. And so a glide reflection is an isometry that is a composition of a translation and a reflection across a line parallel to the translation vector. So here are examples of glide reflections. Notice first you have the feet. That is a glide reflection because it's a translation and a reflection. Next we have the vine. Okay? It's a translation and a reflection combined together. And we call that a glide reflection. Okay, so your assignment then from this section is found on page 386. I need you to do 1 through 7 for tomorrow.